Thank you very much for coming to this parallel session, which is International Hydropower, Sustainability and the Use of Life Cycle Assessment. My name is Xiao Fui. I will be the moderator for this session. So overall, we have 2 hours and 1 hour before the coffee break and then another hour, but we only have 5 presenters for these sessions. So we have ample time for discussion and comments and views. So to begin, I will start with Luis, who is going to uncover the mysterious of death fish in this tropical system. Please.
Thank you very much. Thanks everyone for attending the session and my talk. So I'm Luis Silva. I'm a senior researcher based at ETH Zurich in Switzerland. And today, the topic of the talk would be mass mortality events as a threat to hydropower. And I added that word there, novel, just to tease everyone a little bit about what we're going to talk and, just bring about this effects of mass mortality events that we've been seeing in tropical systems. So I will take you through a journey to some tropical systems and now going down to tributaries of the Amazon in Brazil. But some of these topics that we're going to highlight here are being more widespread, as we can see in this first slide. So the main point driving some of these discussions here is a case study that I'm going to show to you, but most importantly is that we've been seeing an increase at least in the number of fish mortality events reported at different locations around the world. So all of these are news from different fish mortality events, and obviously for those mortality events to show up in the news is because they are large events. Small events are generally not reported. So this has been being a trend or becoming a trend in the news most recently. We have this widespread information of fish mortality events everywhere. So you see a lot of news in Portuguese because in Brazil, where is the study site that we're going to talk about, this has been largely occurring. And we did a study looking into that that generated this report of fish mortality at hydropower plants in Brazil. Specifically, this is available online, and I can give you the reference if you want. And when we looked into that and defined mass mortality events based on the review study from Lyon Cook in 2011, considering that the mortality event, when it's not part of the natural life cycle, or you have more than 25 dead fish in 1 kilometer river or 1 square kilometer Atlantic system within 48 hours, those would be considered large mortality events. Therefore, looking into that, going through news, going through legal prosecution reports at different sites and locations, we came up with this distribution of some of the mortality events that we could see. And you can look here at that the mortality events are widespread in the country from north to south. There is no clear occurrence where we can highlight some of these events, and they vary a lot in terms of biomass that are affected. But there is a lot going on in terms of over 10 tons to over 20 tons of biomass being affected at different mortality events, and those mortality events have different causes. So the main point is to highlight that in the end, we could sum up to over 250 tons of fish that were killed in the last decade by hydropower operation in the country, and then the operation span from turbine operation to spillway operation to water quality problems. But also importantly is that this generated over 150 million euros in fines for the different companies. So we're dealing with both an ecological problem, but also an economic problem for hydropower operators. we took this, and I will just come back here to highlight this specific river, the Telespires River, which is where our study case is located. So we're going to dive into one specific site there where this is Sinop Dam, where we did have some large mortality events occurring. These are some of the specific information about the dam. Most importantly is to point out the 2 Kaplan turbines that they have, the discharge range in the turbines, and the spill gates that they have 3 gates with Krieger-Weir radial gates, and the discharge ranges from 450 cubic meters per second to 6,650 cubic meters per second. The head is not so high, so we have roughly medium head at the dam. And this dam started operation in February 2019. And during that start process, to fill up the reservoir, this was a common scenario at the beginning. So they obviously spilled a good part of the water during the reservoir filling, and this is the scenario downstream of the dam with the spill gates open. So in February 2019, it started operation. Spillway initiated operation as well at that time, and then fish kills started to occur and were reported constantly at that period. That led the environmental authority to, over time, require a scientific assessment of the mortality events. And by that request, I then was invited by ETH, which is a shareholder of the dam, to lead one of the expert panels that were assembled to investigate these mortality events and see what could have been the causes of these mortality events. But importantly, that's what we faced when we were dealing with the expert panel. So basically, you have mortality events that were recorded at the dam from 2019 to 2020 in August. That's the time frame that we studied. So we're talking about 1.5 years of pretty much constant mortality event. Mortality occurring, but the biomass and the number of fish involved, which you can see in the y-axis, they were varying a long time. And there seems to be some patterns in terms of turbine operation. You have turbine discharge here and spillway discharge here. Turbine operation and spillway operation related to those mortality events. So when we were faced with this scenario, we start to dig into different stages, and then we separated different phases, let's say, or periods, where we either have combination of spillway operation and large fish mortality events that you can see with the bars in blue, and these are the numbers in the y-axis with number of fish dead, and this is the Q for turbine or spillway that you can also see with the dashed line. So the green or the black one is spillway, and the red one is turbine discharge. So that was, clearly that we could see some mortality events happening with spillway discharge, and then drops in the mortality events with some drop in the spillway discharge as well. Then turbine and spillway discharge combined, leading to some mortality events. And then, again, turbine and spillway combined. And through those different processes, I'm not going to talk about all of the periods, but I'm going to highlight these 2 here, where we have clearly spillway discharge and mortality events combined. And these periods where we have low mortality events in spillway discharge or low mortality events turbine discharge. So that's what we're going to dive in and look into this presentation today. And also because of this peak in mortality that you can see in the period 3. So when we looked into that, we first assessed what was the magnitude of those different periods and the mortality events there. So here we're talking about the first period with high spillway discharges and increased spillway discharges and how the mortality were occurring at different locations. And most importantly is that we can sum up or summarize the results there, or the mortality events affecting 67 species, 4 taxonomic orders, but 2 were the main ones, crassiforms and siluriforms. They are in tropical systems, at least new tropical systems, the most abundant orders anyway. So, and 42% of the total biomass affected throughout the entire period that we studied was occurring here at this very beginning of the operation. The period 3, where you combine a little bit of turbine discharge with increased spillway discharge, also led to some mortality events, 33 species, 2 taxonomic groups, again, 12% of the total biomass. And this spike you see here is basically associated with some entrainment, fish entrainment in the draft tubes of the turbines during maintenance and operation. So this is a period where we had lower mortality events and more or less stable spillway discharge throughout that period, but still 50 species affected, 3 orders again, and 12% of the total biomass. And that's where we had less biomass affected with 3 taxonomic groups, but 35 species with a combination of turbine operation and spillway discharges. So we ran a model to understand the different components and what might have been influencing more these mortality events or the total biomass affected. And basically what we could see is that a combination of spillway and turbine discharge, depending on the different periods, affected more or were more significant into the output, which was the biomass estimation that we had, as you can see here from the different p-values and the different variables that we considered for the model. And interestingly, if we dive into period 1, where we had the largest mortality event, we also see that some of, or a good amount of the biomass affected and the groups affected kind of correlated with saturation of oxygen. That led us to a discussion, and you can see here in this plot, DO and saturation of oxygen, and these are, the red lines are the ranges where it is still safe for aquatic organisms and fish, and if you go beyond this or below this, it starts to become a bit dangerous. And we can see from saturation of oxygen that some of these values go way above that limit during certain times of operation there. So based on these results, like, we concluded that some of these mortality events were actually a combination at different times of, as I said, spillway discharge and turbine operation. But looking into the fish injuries, we saw that for certain periods there were fish, a high number of fish with gas bubble disease injuries, and another large number of fish sometimes with physical injuries likely related to turbine effects. So either blade strike injuries or biotrauma symptoms and so on. So there was a mix in that assessment, but the large or the vast majority of the mortality events were related to spillway discharge. So that led to conclusions about management solutions that we discussed in the short, medium, and long term. And that led to the development of this ecological and technical ambitious program by the operator. In the short term, they initiated control of the spillway operation, but obviously that control is somehow constraining the operation at times, and therefore other solutions in the medium and long term, such as spillway design modifications, are currently under discussion. And we are now initiating a program to identify supersaturation thresholds that would affect tropical fish, which is not known in the literature. Also, we discussed a lot of these considerations about potential synergistic effects of water quality parameters with some of these fish mortality events also. And yeah, that's it with that. I would like to thank my co-authors in this abstract as well. Leah Becci is here, and Vicent, also from EDF Friends. And thank you very much for your attention.